Jessica Academy. Kindly subscribe if you have not subscribed. Share with your friends also on this channel so that they get to know every bit of tutorials that I normally post in this channel. Kindly subscribe. Now today we want to look at isolated point. And this is a topic in introduction to real analysis. So let's move together. A point A in a given set A is called isolated point of A if there exists a neighborhood of a point A in N such that that neighborhood is actually that element A. That's not enough, so it gets itself. Okay, a point A in a set A is called isolated point if A, that's a set A of set A, if there exists a neighborhood of that point A in M such that that neighborhood only consists that point. So if you happen to consider that point, it is isolated point. If you look clear at this from the previous tutorial that I have already looked at about limit point, you'll find this is actually an opposite of limit point, because a limit point allows a neighborhood to have another element which is not A. If you have that another element which is not A, that other element becomes a limit point. But in this case here, we have that particular element itself. There's no other element. So that element now is called isolated point. It's saying to be isolated point. So the point N contains only, remember this N is the neighborhood, contains only point A. Thus a point A in A is isolated point of A if it's not a limit point of A. Not that. It's not a limit point of A. If it's not a limit point of A, then it's isolated point of A. Okay, let's proceed. Closed set. Let X be N set. This is the definition for closed set. So let X be N set, and we have S, which is a subset of X, or is equal to contains both in full in X. Then X is saying to be closed. This S is saying to be closed if it contains all its limits. It contains all its limits. So if you have a given set X and you find that we have another subset S in it, and you find that this subset set is contains all limits of X, then you know that S is actually a subset. It's actually a closed set. So what do you test for closed set? You just look at whether all the limits are inside that subset. If that happens, then so that's a closed set. That's the only tip. So for example, if a finite set is always closed. A finite set is always closed. A finite set is always closed. Because why are we saying it's closed? Because its derivatives and derived set, which is a set of all limits points, is actually null, same empty for any finite set. So this is true, and it actually follows like that. It is true. B. The null set is obviously closed. That's trivial. The real set is closed. It's a closed set. Okay. Then a rational set is not closed set. not closed set. Then the sets, that one, and this one are not closed. Of course, you see they are open, either lower, upper, or both sides. So they are not. You find they do not get any limit. So they are not closed. But if you look at this one, it is closed. It's closed. Now let's look at this set here, S, which is given this. So if you look at this, you'll find that it contains a limit 0, but this limit 0 is not inside S. Okay? Therefore, this S is not closed. It's not closed. It's not closed. Remember, every limit should be in, every limit point of S should be in S. So in this case here, 0 is a limit point of S, but it's not in S. And therefore, that makes this set to be not closed. Okay. Let's look at our theorem. If you have not yet subscribed to this channel, kindly subscribe. Share also with your friends. And also revisit the other subtopics that we have looked previously. They are very helpful. A set S is closed if and only if its complement is open. So a set S is closed if and only if its complement is open. Let's prove this. This is if and if proof. So to prove this, that the complement is open, we let S to be a member of that. And if it's a member is X is a member of the complement, to imply that then X is not a member of S. Okay. Now since S is closed, because already you've seen that set S is closed, you know that from the theory, then X is not a limit point of S. Because S is closed, do you know the meaning of being closed by definition of closed set? Then we know obvious X will be not a limit of this because it is not in S. It's not in S. If it's closed, remember every limit should be in S if it's closed set. So, but in this case, it's not closed because X is not in S. So, by that, with that, we see that if you take a given epsilon, post epsilon, and we check the neighborhood of X, you find that it contains no point of S. It contains no point of S, and therefore, if you look at this, you find that it contains members of the complement. It contains the members of the complement of S, and it will mean that the complement is a neighborhood of X for nx in the complement of S, and therefore if that is true, then it will mean that the complement of S is open. The complement of S is open. So you have seen that we have shown that the complement of S is open by that fact. Now, because this is if and if, so conversely, to prove that this is that S is closed, let X be a limit. Let X be a limit point of S, and we need to show that now this X is in S. So if you let this X to not be in S, it will mean then it is in the complement of S. And if that is true, because X is a limit point, it will mean that it is open, that S is open, and therefore it will mean that the complement of S is a neighborhood of S. It's a neighborhood of S, X, and this implies that there exists a positive epsilon such that if you look at the neighborhood of x, it will find that neighborhood of x will be found in it will be contained in the complement of s of s. So this will imply that it contains no points in s, and if it contains no points of x, from what we are saying, because already we are saying that x is in x, that becomes a contradiction. And thus x, it will mean x is not a point in s, which is a contradiction, and therefore it will follow that our set S is closed. It will be closed. Okay, so that is it for now. If you have a question on this, kindly leave a comment, share also with your friends, and don't leave until you subscribe. Bye for now.